Welcome to Metallurgy Lecture number 13, Corrosion. And living in Western New York, when people think of corrosion, they think of their cars, right? They're screaming out there right now, not just the Toyotas. Every car out there will eventually turn into a pile of rust unless it's made out of plastic. Saturns are made out of plastic, right? They used to be. Maybe they found out that, plastic in a car crash is less than desirable. I don't know. I don't know if they still are. My buddy had a plastic Saturn. You could kick the door. Yeah. The hood was the only thing metal on it, I think. But when people think of corrosion, they think of cars, especially in Western New York. Now, if you live in Florida, not so much, but in Western New York, cars disintegrate, right? Rockers rusted out, and we got rusted out rockers in here. I guarantee it. Somebody's got it. Nobody? Oh, you do? Gone. Just
bed's gone.
Gone.
Frame's gone.
This thing shouldn't be rolled down the road at all. It really shouldn't. No. You can pass your inspection. Your lucky New York State inspection.
He knows the guy.
You slide the 20 under the door before you go in. Whew.
Engine light was on too when I took it in.
Uh-huh. You're suspect, pal.
I'm driving, aren't
Types of corrosion. The first and foremost, actually it's not the foremost, it's just the first. Crevice corrosion. Liquid fills a crevasse, causing a depletion of metal ions. This then can cause pits. And then the notes get real specific. It says, which eventually may cause a pipe to leak. Why they went right into pipe, I don't know, but anybody know little crevices that would cause this? It's more of the welding people question. There's a weld defect that they're really strict on, right?
Oh, undercut.
Undercut, right? We'll look that up here as soon as I see people stop writing, which is pretty much now. In the machinist world, they don't have to worry about that. There's a weld defect that's called undercut that is basically little crevices on the sides of the weld, and they're allowed to have a tolerance of 1/32 of an inch before it becomes unacceptable, so it's really small. And the welders all complain when I give them grades when they have the entire side of the weld of undercut, and they yell at me and say, what the heck? You're allowed a 32nd. And then I usually pull out a caliper with a 32nd, and it's like the size of a business card, right? So you can see like right here. Can you see that up there? Yeah, the little indents right there. Sometimes they'll bring it to me and it's just massive undercut. Right here's a pipe, what they were just talking about, right? See them little indents? Now, undoubtedly they're going to paint that, but when there's water sitting in that constantly, eventually it's going to break, right? Long time, but let's look up Crevice Corrosion. Whoops. Crevice Corrosion. Sitting in a flange. And that's what it eventually turns into. This is the scientific thing they're doing right here. We're not there yet. Crevice corrosion. That's on a flange, which probably was welded. obviously, if there's a little cup for water to sit in, it's gonna cause problems, right? So it's pretty obvious why that would happen. Tuberculation. And this is tuberculation and underpositive corrosion, what we're going to go over here in a second. When this happens, if you're ever fixing something, I always think of like a plow truck. Somebody brings you a plow and says, there's a hole in my plow, can you patch it? What happens when you hit it with a hammer? The plow disintegrates onto the floor, right? And that's because of tuberculation and what we're going over next. You just hit it with a ball peen hammer and rust just rains down, right? So, tubercles, we have to look up the pronunciation on that, are mounds or clumps of corrosion product that cap localized corrosion activity such as pits. Almost looks like barnacles, right? Which is a swear word in SpongeBob.
So is Barnacle Boy. Or so is Barnacle, so what does that make Barnacle Boy?
He's a walking, I don't know, swear word, I guess. Tuberculation.
Switch that up one more time while I'm right.
Sorry, man. I'll go back. Everybody's seen this before in some way, shape, or form. And when you remove that, it basically, so when you have that going on, when you remove it, it basically takes away all the product, right? Like I'm saying, like a plow, it'll be bubbled up, right? And then you hit that little cap out, and it's gone, right? You no longer have metal there. It's usually pretty bad.
I might be wrong, but isn't that pretty much what all Buffalo's water pipes look like right now?
Well, I
Like,
have no idea.
I think that's exactly the problem they're having. The infrastructure is so old that the diameter is so shrunk because of that.
Look at this one. Water main break clock, whatever that means. So it's a water main break, and look how much area is missing from that to have water flowing through it, right?
Isn't that unhealthy?
That's why you're supposed to have one of them little filters on your house. I put one in my house, and
All the city water
it would
do it.
clog so frequently, I just said, get yourself a Brita.
Is that the one you put in the fridge?
Yeah.
It's a pain in the ass.
I don't like my water fridge cold.
Me
It's too
neither.
cold. Can't drink it. If you need water, you want to chug it, right? I don't know. Maybe not.
Just man up and drink out of the friggin' tap.
That's what I do. That's the big deal though, like, why is the cancer rate so big in this area? Is it because of the tap water?
No.
Well, think about when a farmer puts all them chemicals on a field. Where's it go? Right?
Good for you.
What is that? Triple 19. Yeah, triple 19. A glass of triple 19 is great for you.
That's why there's only one thing you drink, and that's water.
Under deposit corrosion.
Right next to the county line.
Is localized corrosion that occurs between the tubercles and base metal. Is localized. Well, it doesn't like under deposit. Let's see what do we do. Wow. Okay. It is localized corrosion that occurs between tubercles and the base metal. So under those tubercles. We're gonna look that up here in a minute. If there's moisture under there, it's locked in, right? So that's why it's gonna have that under deposit corrosion. Is the Cookie Monster done writing yet?
Mm-hmm.
We still gotta find a logo for you.
So what exactly is that in them? Brent,
Hmm?
what exactly is that in the pipe? Like, what is that?
This is rust.
Oh.
Gross. Tubercles.
Tubercles. Tubercles.
Well, you're right. Ooh, look at that. Pops right up. Figured they'd have one pulled apart. There's, look at this. Look at the pipe, how it's eating away at the bottom. Of course, when you're thinking about a pipe, if it's laying on a pipe, it's always going to be on the bottom more, right? So it makes sense. I was hoping they'd have a pit that they pulled out of here. I guess kind of right here. Gone, right? Look at this one. Gone. Our one of our adjuncts in Olean has a company that works for a company that makes Band-Aids for these. So they make stainless pipe that go around. Well, it's stainless. I don't want to say pipe. It looks like a. Well, I'll show you. I know the company's name. Let's see. Whoops. There you go. We did a training for the BPU one time in here, and they had these things all on their truck. And when they break a water line, they just put one of these on it, and it still leaks. I was surprised that they do that. For pipe repair. See, right there it is. So it's stainless, wraps around, they tighten those bolts. Now, does that look like it might leak?
Yeah.
It's kind of scary, isn't it? But I guess that's what they do. I don't know. It's a clamp. It's a good term, right? Clamp. It's basically a clamp. A clamp. Water pipes, they're not under a lot of pressure. Oxygen corrosion. When dissolved oxygen is in the water, it will attack normally passive metals. Such as copper. So where's there a lot of oxygen in the water? Where there's turbulence, right? A good spot near here would be Niagara Falls, right? Anybody not been to Niagara Falls when you're from the area? Well, you're not from the area.
It's not like you've been here for 10 years.
That's a jackass.
He's only been. Whoa, keep it PG-13, please.
Oh, my bad, I forgot. My bad.
Well, that water going in there is just pumping it full of oxygen, right? Like a fish tank. What do you see in a fish tank? They need the oxygen in the water, so what does it do? It just circulates it, right? It has that little. Aluminum will remain unaffected. By dissolved oxygen because of its adherent Oxides. So aluminum has a big enough oxide layer on it that it won't be affected by oxygen corrosion. That's why aluminum is our favorite material. It's my favorite material. Heavily oxygenated water. Wears aggressively against zinc or galvanized pipes. Zinc, galvanized, same thing, right? They're going to put zinc on it so that it doesn't break down. Oop. Well, I can go. You saying you need to go up higher?
Yeah,
To where? Here?
yeah.
How long?
That's probably good right there.
Going back down. Alright. Oxygen corrosion, images, that kind of looks like it's stainless, doesn't it? See, boiled water, that's a good one too, you know, get them gases coming through it. Not very many good pictures of that one. Next. Biologically influenced corrosion. This is kind of a cool one, right? A more interesting one, let's say. When this was happening a long time ago, it was baffling people, right? Why is this breaking down? Because the little isms are messing with it, right? The isms. Small stuff, that's what I call small stuff. That you need like a microscope to look at. Isms. Sulfate reducing bacteria. You're going to see that with the blind eye?
Isn't that what's happening to the Titanic?
The Titanic.
Yeah, it's got like bacteria.
Oh, I'm sure. It's in the bottom of the ocean, man. Probably all kinds of horrible stuff happened to that thing.
This whole thing that said there was like metal-eating bacteria on it or something.
Yeah, I'm sure. Sulfate reducing bacteria. I find it kind of hard to believe they can't get that out of the bottom of the ocean. You would think with all the stuff that's been going on, the movies and the...
You seen it recently? The freaking thing is there's nothing left barely.
Yeah.
Yeah, it's probably been
It's
in
like
there for how long? When did that Titanic sink?
1912.
Really?
Yeah.
I was thinking like 40s for some reason. Yeah, that thing's messed up. To move it now, it'd probably just crumble, right?
I said it, just break into a bunch of pieces.
Did you guys hear about the bomb they found in Poland? Basically,
You
like
know
a
they
small
saved the
nuclear
pilot
bomb,
cockpit
just
from
sitting in
9/11.
yeah.
Sulfate reducing bacteria.
They had like, you know, they had oil.
Yeah.
Or they had the cockpits.
They're trying to,
Some bacteria
undo it so that it will, like, upset the.
lost it. Produce acid
Yeah,
that attacks
like a mile away
metals. So acid producing bacteria, sulfate reducing bacteria. Some bacteria are metal depositing, causing oxidation. Are metal depositing can cause oxidation. So sulfate reducing, acid production, metal depositing, and now we're going into slime. Some form slime, which contributes corrosion by consuming oxygen and stimulating the formation of oxygen cells. So slime production, just creating oxygen. Still writing? Look at that. Sulfate reducing bacteria. I wanted to see the real parts. There you go. You can tell what that is, right? That's a break wall. I'm assuming that's a break wall. Everybody's seen a break wall, right? Been to Dunkirk. I think there's a couple ones to talk about.
Barcelona.
Barcelona,
Yeah,
yeah.
people died on that one.
What, the one in Dunkirk?
It makes sense that seawater would have this bacteria, right? Especially in, you know,
People are freaking idiots.
I don't want to mention the lake that's local that has a lot of bacteria in it, right?
Oh, all right.
I mean, you look at Chautauqua and what, it's like pea soup, right? Then you go down to Kinzu and it's like, wow, it's so clean. That's clean water. But that's where you're going to get that bacteria, right? Great Lakes accelerated?
Oh, look at the
There it is.
Titanic.
Yeah, look at the Titanic works now.
We'll do that after we're done with the notes.
It portrays to this part of the notes.
We'll come back to
It's
it.
got bacteria.
Like that? We'll look it up after notes. I wouldn't want you to get it cheated out of your notes. I know how you love them, so. Where are we at? Stress corrosion cracking. That thing, I want to go back. Oh boy, bad things are happening. Oh, there we go. This is a phenomenon that people have been working on for many, many years trying to figure this one out.
It's a what?
Phenomenon. I told you I can't say that word, and yet I keep trying. You've never heard me say that before? I say it all the time.
Sound like you're having a stroke. Are you okay?
We're all good up here. We're talking about stress corrosion cracking, which occurs in austenitic lost it. Stainless steels due to interaction between tensile stress and a particular corroding. Didn't like corroding last year either. Oh. It's because it was misspelled. I was writing the notes, or the test for this yesterday, and I wrote corroding, and it kept correcting me, and I finally looked it up in Webster's, and that is the correct, it's with an E. But in Google, it wouldn't recognize that that's a word for some reason. Stainless is unstoppable, right? Not really. Look at that. There it is. And you can see the corroding would probably be iron in this one, right? Cathode, anode. We're going over galvanic corrosion next class. You're going to be hearing that a lot, so. Stress corrosion cracking. Corrosion fatigue, right? Anytime you hear fatigue, it's going to be a cycle of stress, right? Generation of cracks resulting from the combined effects of cyclic stress and corrosion. Cyclic stress. Your car could kind of be considered that, cyclic stress, right? Vibration. Usually they show a pipe with this. Or no, that's erosion corrosion, my fault. But you can see right here. Gone, right? Gone. The next one, erosion corrosion is what I was thinking. If you put it on a 90 of a pipe, usually it's eroded where the 90 is, right? Erosion, corrosion is the accelerated degradation of a material due to the cyclic stress whoops, my bad, I knew I was doing something wrong. Due to the action of corrosion in combination with erosion by rapidly moving liquid. Moving water is very powerful, right? We have the benefit of having someone from Louisiana in the course today. Have you seen any erosion by moving water in Louisiana?
Oh,
There was this thing called Hurricane Katrina, right?
yeah.
Some would say living below the sea level, though, is just a foolish thing to do when you're by the sea.
Well, not at all.
Erosion corrosion. Water is very dangerous, right? In a glass of water, it's not dangerous, but when a hurricane comes through, very dangerous, right? Very dangerous. Anybody ever get in a bad undertow? It's pretty scary,
That's why people died in breakwater in Westville.
right?
Erosion.
Erosion.
Swimming pools.
There you go. That's a good one. That was probably on the bottom, right? So you had constantly flowing liquid, which eventually rusted and then failed. Usually there's a 90 right there. That's a good one right there. So you can see it right here. That water's coming through and getting all turbulent when that 90 hits, right? So that's why it's eroding and corroding. That's a copper tube. So that shouldn't break down at all, right? Erosion corrosion by nitty gritty. Think about if you had sand in that water. It's basically, I don't want to say like a sandblasting with fluid, but it kind of is. Last but not least for the day, de-alloying. You know where this is going, right? It's in the word. It's pulling the alloys out, right? So it occurs when alloying elements are separated and corrosion occurs. Stainless does not rust, right? What happens if you put a piece of carbon steel on top of the stainless? The stainless starts to rust, right? The same thing with aluminum. It'll start to oxidize and it'll break down. That's why you're supposed to store that stuff separately. Many people don't, however. It does take a while to do, but let's go over here. De-alloying corrosion examples. Ooh, look at that. It's going to explain it. Is that a building? I gotta look at it. Oh, that's an institute. De-zincification, which is a selective removal of zinc and brass alloy. So it's pulling the zinc out. Similar processes occur in other alloy systems in which aluminum, iron, cobalt, chromium, and other elements are removed. That's all the stuff that keeps it from rusting, right? So if you pull it out, it's going to rust. Or break down, I guess I should say. Those are all types of corrosions. So next class we're going to go over galvanic corrosion and what causes it, how to prevent it. We have a lot of people that, for the capstone courses and things, they make trailers. And we always make them out of aluminum if we do that, for obvious reasons, right? But to prevent galvanic corrosion, there's things you can do to keep that from happening, and we will do that when we're in our capstone courses, and we'll go over that next class.
Can we make it 30-foot movement?
If you have funding from some other source, we'll go over that in capstone. The welders have a capstone course, they have to build something, an actual project.
Or make it
We
40?
need to put ours, Mike, on the bottom, yeah, 60.
Any questions on the notes before I turn the video camera off?
Even DOT.
Clearly none.